all, I want to say thank you for organizing this webinar, and thank you to all of the previous speakers for their interesting presentations. In the next 5 minutes, I'll be going to talk about fMRI-informed TMS, specifically in the field of substance use disorders. And if you want to have my slides, you can scan this QR code. Next. In 2019, we published a paper and collected all of the previous TS and TMS studies in the field of addiction medicine. And next. And we reported that by the end of 2018, we had 50 published papers that used TMS for substance use disorders. Next. And now, only after 4 years, we updated our systematic review, and we found that by the end of 2022, we had 119 published papers that use TMS for addiction medicine. And it means that the use of TMS has significantly increased in the field of substance use disorders. Next. And our results showed that people targeted different parts of the brain to enhance drug-related behaviors. And the most commonly used target was the left dorsolateral prefrontal cortex, but other brain regions such as right DLPFC, the frontopolar cortex, insular cortex, and many other brain regions were also targeted. Next. And we also found that people use different methods to place the TMS coil over the targeted brain area, and the most commonly used method was EEG standard system. And other methods such as 5 centimeter rule, neuronavigation system, and BMF3 method were also used. Next. And these results show that there is no specific agreement on target selection in the field of substance use disorders, and there is no specific optimization or individualization in this field based on functional neuroimaging maps. Next. So, inspired by previous studies in the field of depression, as discussed with previous speakers, we thought that next, if we might be able to enhance the stimulation outcomes by targeting the most negative connectivity between the DLPFC and subgenual cortex in the field of depression, how we might be able to optimize, individualize, and inform TMS target selection in the field of addiction. Next. And so we started to put together different sources of evidence, and we found that in different types of studies, such as lesion-based studies or fMRI drug cue reactivity tests, based on the database that collected from different parts of the world in different labs, the frontopolar cortex plays an important role in the field of substance use disorders and in people with various types of substance use disorders. And next. And we also found some previously published papers that targeted this brain area by placing the TMS coil over the FP1 or FP2 locations, and they reported some promising results, but they didn't use any individualization for their target selection to target these parts of the brain. Next. And we also found some evidence that reported that the resting state functional connectivity between the ventromedial prefrontal cortex near the brain area that we named frontopolar cortex and the left medial amygdala is a marker of early relapse in people with substance use disorders. And next. And our fMRI drug cue reactivity task also confirmed that the functional connectivity, task-based functional connectivity between frontopolar and left medial amygdala can be found while people were exposed to drug versus neutral cues. So we hypothesized that the connections between frontopolar and left medial amygdala can be considered as a circuit that can be targeted by TMS in this field. Next. So we started to find the individualized location for a group of 60 participants with methamphetamine use disorders based on the most positive connectivity between the frontopolar cortex and the left medial amygdala. Next. And based on the task-based functional connectivity analysis, which is named PPI connectivity, we found the most positive connections between these two brain areas for each person, and we found a large inter-individual variability in terms of location and strength of the connectivity. Next. And we also found a significant correlation between the extracted functional connectivity and craving score after drug cue exposure across the population. So we found individualized location for each person based on the most positive connectivity between frontopolar area and the left medial amygdala. And next. In the next step, we try to optimize coil orientation over the individualized target, and we found that by optimizing the coil orientation over personalized location, we can significantly increase the electric field intensity over the targeted brain region compared to fixed FP1 or FP2 fixed location. And next. And then we adjusted the stimulation intensity across the population to have identical electric field intensity for all of the participants. And next. And we think that this pipeline can be used to optimally and individually target the frontopolar amygdala circuit in people with substance use disorders. And our pipeline is now available online on medRxiv. And we are going to test this hypothesis in a clinical trial, and we hope that we can find significant results. And I want to say thank you to all of my mentors and all of the colleagues that helped me, and thank you so much for your attention.